In today's video, we are going to talk about the thermoregulation because how exactly the body regulates its temperature. You may have observed that whenever you go to the cold places where the temperature is very low, then you may have realized that your feet may become very cold. But if you check your temperature of your body with the help of thermometer, then you will find it will be almost around the 37 degrees centigrade, which is considered as a normal temperature. Uh, Despite the fact that the temperature of your hand or your feet may be very low. Uh, why so that's why exactly it happens that despite having a very low temperature at the periphery of your body, your temperature of the your core temperature still remains at around 37 degrees centigrade. It is because of the fact that we have a lot of subcutaneous fat beneath our skin, which actually prevent this heat from getting lost. So that's how body keep its temperature high or at a constant level. Why exactly this temperature is required? Because if the temperature goes down below the 37 degrees centigrade temperature, or it goes up, then all the activities, biochemical activities taking place in the body is going to get affected. That is the reason why body try to keep this temperature constant. And this can be done with the help of hypothalamus, because this is considered to be the main actually controller of the temperature. So if the temperature goes up, then it will try to bring it down. If temperature goes down below the 37 degree, it will try to bring it up so that the constant temperature can be maintained. Now this temperature, whether it will be high or it will be low, depends upon the the difference between the heat generation and heat loss. So there can be many mechanisms. There are many mechanisms through which the heat can be generated in our body or it can be lost. So the first mechanism is the muscle activities. So if you suppose if you start exercising or if you start running, then because of the increased muscle activity, the temperature is also going to get increased. Whenever you eat some food, then also your metabolic rate is going to become high, and that's why the amount of heat generated in your body also will increase. Then heat also can be gained from the environment also through the process known as conduction, convection, and the radiation. Conduction means that if you come in contact with if you touch any hot object, then this some amount of heat is going to get transferred into your body through the conduction. Radiation means that every object radiates some amount of heat. Your body also radiates some amount of heat. So through this radiation, you can also get the temperature down. Also, at the same time, you can increase. Also, you can gain the temperature from outside. Also, depending upon whether your temperature of your body is higher than the surrounding, or the temperature of the surrounding is higher than your body. If the temperature of the surroundings is higher than your body, then you are going to gain the heat from the surrounding atmosphere. So that is also, you can, through the radiation, you can gain the heat. Then in the same manner, you can lose also heat through the process called as conduction or radiation or convection. Conduction means if you touch some cold object, then some amount of heat is going to get transferred to this cold object. Radiation, as we have already discussed, like if your temperature of your body is higher than the surrounding, then some amount of energy is going to get lost. Then you have a convection also, like if you have a if the cold waves or cold air keep on blowing over your body, then it definitely some amount of heat is going to get lost from your body. So this is convection. So these are the mechanisms through which you can either you can gain the heat or you can lose the heat. So your body temperature depends upon the difference between the amount of energy that you gain and amount of energy that you lose. So this is what. Now how exactly the hypothalamus, how this now hypothalamus will try to maintain this temperature at a 37 degrees centigrade. If the temperature rise above the 37 degree, then definitely it will try to bring it down. Or if it goes down below the 37 degree, then it will try to bring it up to the, so that the constant temperature can be maintained. This is done by the hypothalamus through a lot of mechanism which we will discuss. So suppose if suppose if the temperature of surrounding environment is higher than your body, then you may feel hot, and that's why your temperature of the body may increase. But what exactly hypothalamus will do? It will actually it will be responsible for the dilation of the capillaries which is found just below your skin. So these capillaries will get dilated. So when they will get dilated, then more amount of blood will start flowing in these capillaries. And when the more amount of blood will start flowing in these capillaries, then some amount of heat is going to get lost. So this process is known as vasodilation. Vasodilation. That's how the hypothalamus can, once it receives the signals through the what is called as thermoreceptors, because these are the two different type of receptors. These thermoreceptors is found in the all in our skin. These are free nerve ending. So whenever the temperature of the surrounding is suppose more than these thermoreceptor, more than 37 degrees centigrade or less than 30 degrees centigrade, then this thermoreceptor will actually give this stimuli to the hypothalamus. And these are the two different type of thermoreceptors, like one is one which is located in deep and some are superficial. Like superficial are those receptors which are located in our skin, whereas the deep receptors are located in the esophagus or abdominal vena cava. So these all the receptors, whenever the temperature fluctuate from the 37 degrees centigrade, then these receptors actually give this information to the hypothalamus, and then that's how hypothalamus will start acting to bring this temperature again to the normal. So these are the thermoreceptors are also two types, because they like some are hot receptors, hot thermoreceptors, some are cold thermoreceptors. Hot thermoreceptors are those receptors which give this information to the hypothalamus whenever the temperature goes above the 37, whereas the cold receptors are those receptors which uh, gives which receive which gives this information to the hypothalamus when the temperature goes below the 37 degree centigrade. So once the hypothalamus actually receive these signals, then it can act upon this information, and if suppose the temperature of outside is more than the 37 degree, then it can uh, lead to the vasodilation. Then there is another also mechanism through which we can lose our heat, that is through the our sweat gland, because if you see the in the skin, you will find that there is a sweat gland here. So when this sweat gland they start secreting this sweat, that will come through the sweat duct and will get deposited on our skin. So once this sweat will get evaporated, then it will also be responsible for that, for cooling down our body, because whenever the water will change its state from liquid to the vapor, then generally this process of evaporation requires some amount of energy, and this energy will be taken from our body, so that's how the temperature of body will decrease. So these are the another mechanism through which the temperature can be reduced. Then if suppose if the temperature of outside is cold, then you have another mechanism. If the temperature of the surrounding is very less, then this temperature can be maintained through the process called as vasoconstriction. In the vasoconstriction, the capillaries get constricted. Vasoconstriction. So when the capillaries will get constricted, then the amount of blood flowing in these capillaries is going to get reduced. So consequently, we will lose less amount of energy, and that's how we can preserve the heat. So this is called as vasoconstriction. Through this process, also the temp in the cold environment, the temperature can be maintained. Then there is another mechanism, that is shivering. Whenever we shiver, this is an involuntary movement of skeletal muscles. So whenever we shiver, then the muscle activities increases, and that's why it produces more amount of heat. So through shivering also we can reduce. Then non-shivering mechanism like thermogenesis. Whenever if you remain for a long period of time in a cold environment, then more amount of thyroxine is released by the thyroid gland, and which in turn will increase the metabolic rate, and that's how the more amount of temperature energy will be produced. So this is another mechanism that we have. But we have to also understand, if the temperature goes above the 37 degrees centigrade, this kind of condition is known as pyrexia or fever. If the temperature of the body goes beyond the above the 37 degree, why exactly it happens? So that we have to understand why exactly the temperature can go above the 37 degrees centigrade. It is because of the damage of some of the tissues, or maybe because of the bacteria or viral infection. So whenever bacteria enters into the body, then or virus enters into the body, some component of this bacteria virus they get mixed with the blood, and that's how whenever they reach to the hypothalamus, then hypothalamus receive this information that the body has got infected. These are known as pyrogens. So once this hypothalamus receive these signals, then the set point of the hypothalamus increases. This process is known as prostaglandins. because earlier the set point of the hypothalamus was 37 degrees centigrade. Now it is going to get increase. So whenever the set point means, like you may have observed the thermostat generally that is found in the fridge or AC. So whenever you set a point, then if the temperature dips below this point, then immediately automatically the fridge will stop working, because so that's how this is the same kind of set point. So 37 degree, earlier the set point was 37 degree, because if the temperature went below the 37 degree, then the hypothalamus one started bringing it to back to the 37 degree, or if it went beyond the 37 degree, then it tried to bring it down to the 37 degree. So that's how earlier the set point was 37, but because of the viral infection, once this component of bacteria virus they are received by the hypothalamus, then the set point increases, because uh, this is now the set point, because our immune system works in a in a high temperature, that is above the 37 degrees centigrade. So that's why now this is a set point. So the temperature of the body will increase. Temperature of the body will increase to this set point, and then if suppose infection is abated, if the infection is abated, then the temperature will again start falling back to the this set point. So set point will also be lower. So that's how it actually works. So once the infection is abated, then again you have the temperature will start moving down, and this is the set point will also be lower down. So at this point of time, because set point has already gone on to get increased, the this at this point of time the patient will actually experience the cold. Why? Because it will experience the cold, because the set point is high, means this is the point that the hypothalamus want to achieve, but the still the temperature is low. Here in this part temperature is low, so that's why the patient will feel cold, because this is the temperature that hypothalamus want to achieve. And then again here, the when the temperature will go down, then you will find that still the what is the set point is higher, but temperature is dipping down. That's why the patient will feel hot. That is the reason you may have realized that whenever you give any antipyretic drug, then the patient will feel hot. So this is how actually this point is also known as crisis point, because when the antibiotics was not invented at that point of time, people used to wait for this point, because if anybody uh, successfully passed this point, then his temperature used to his temperature would go down and he will be recuperated. So that's how this hypothalamus actually maintains its body's temperature.